Hi, and welcome to the introduction to the second session of our Laying Firm Foundations unit. As with all of our short video introductions, I know that I can only give just a taste of what the session covers in total and just how practically it can help build a far greater confidence of teaching computer science. However, I hope I am able to get across the central aim of each of these sessions, which is to directly help teachers to further enrich and broaden their teaching practice through clear practical approaches to the teaching and learning of computer science in Key Stage 3. Along with this, as with all Tenderfoot sessions, it will help you to build an extensive buffet of practical resources, teaching ideas and subject knowledge that you, your team or your learning community can draw on, adapt and use in many different ways to help enrich the Key Stage 3 curriculum. As these videos are designed just to show a brief outline of the content, support and resources available within each session, I recommend that after watching this, that you visit the Tenderfoot program online, the link to which will pop up throughout this video and will also be available at the end and in the written description below, as will the link to join CAS and get them. But for now, let's introduce this session. Essentially, it follows on from the previous session and focuses more closely on those small number of core concepts and constructs that lay at the heart of successful teaching and learning of programming in Key Stage 3. At the same time, it moves on to how these relate to and are used in structured programs. As always, the full session is structured for participants to come away with very clear practical development outcomes and practical teaching activities to accompany them. In this session, these are to be familiar with the key concepts required to write programs, to recognise the key constructs used in every algorithm, to appreciate the centrality of a variable, to be familiar with functions and procedures, and to recognise their role in structured programming. Alongside these specific outcomes, the session puts computational thinking at the heart of our teaching and learning of computer science, as we know that developing computational thinking is at the very heart of pupils developing as computer scientists. Therefore, computational thinking is explored and reinforced across this session as with all other sessions. And, as such, Session 2 continues to consider practical computational thinking alongside those three main constructs for creating algorithms, and, while doing this, it introduces alongside them another central concept that goes hand in hand with algorithms, that of data structures. Algorithms plus data structures equals programs is an old but well-known book written by a computer scientist called Nicholas Wirth, who developed the programming language Pascal. He gave the book that title to sum up the challenge that faces programmers of all levels and all experience. The simple challenge that programmers need to develop algorithms which manipulate data. In fact, as the session continues to explore, it is the use of data structures alongside algorithms that makes programs as useful as they are. Without data structures, programs wouldn't be able to solve many of the problems or carry out the tasks that we need them to. In this session, this is explored through the relatively simple yet absolutely key concept of a variable. A variable may commonly be viewed as the simplest form of data structure, but in truth it can be difficult for some pupils to understand conceptually and then employ practically. So to help us do this in the classroom, the session teaching it beginning from a very simple definition. That a variable allows an algorithm to store, retrieve and manipulate data. And, along with this simple definition, it also starts by making use of a simple yet clear conceptual approach. That a variable can best be conceived as a container or a box with a label into which a value can be placed, and that this value can change, but as the session explores, the container can only ever contain one thing at a time. Using these simple definitions and concepts really allows for pupils to build up a strong and gradual understanding, while avoiding cognitive overload along the way. And it enables pupils to embed these initial concepts and ideas, which allows for greater progression without misconception. So, using this simple concept and definition as its starting point, the session goes on to look at the role and use of variables alongside the three key algorithm constructs, and exploring and unpacking all of this through practical hands-on activities and investigation. It begins by looking very practically at how all this can come together in the form of a counting program within Scratch. Here is the code. You see, children learn best when they are able to explore and discover the properties of such things as variables through practical challenges, and here, this exploration is encouraged through practical investigation and guided observation, so that pupils are able to build upon their own mental model of how variables work. So here, with the counting program code in mind, we might want to try a number of things with children. We might ask the students to predict how the code will work, how they might modify and adapt it to change what happens in various ways. We might even want to explore how this can be achieved in unplugged ways to get the children to execute the code physically and learn from that chance to explore living code. It also explores the importance of repeated exposure to concepts in learning computer science and why it is so important in children's progression. Here, the session looks at how this might be done by further exploring variables in another activity called drawing a spiral. As well as providing a good way to practice applying the concept of a variable and building a greater understanding of the role of data structures, this activity also allows for plenty of potential extension challenges, great differentiation and some powerful visuals. And, through its use of Scratch, the pupils can investigate using tools and techniques that they already should have experienced, but in new ways that can help us as teachers begin to really highlight the development of computational thinking skills. In this case, generalization through pattern matching and decomposition. At the same time, it is looking at the activity from the point of view that programs are built up of algorithms acting on data structures, and there is no doubt that repeated exposure helps pupils to build a greater practical understanding of the role of variables and other concepts. The session then goes on further to explore the teaching of decomposing big problems into smaller ones and how complex programs are built by assembling smaller blocks of code. In this case, it is welcome to Wacky Races. With Wacky Races, the session continues by looking at teaching variables through a more challenging activity as a way of really getting to the heart of teaching and learning those key computational thinking concepts, and in particular to engage with the ideas of decomposition and abstraction, as well as learning more about functions and procedures in code and structured programming as a whole. As you can see, the program might look complicated. However, in the session, just as we would in the classroom, it will look at how we can use our knowledge of decomposition to promote discussion of the task and how this might be broken down into more manageable chunks. We can begin by the task of drawing out 3 or 4 distinct areas that could be developed independently. For example, the race setup, the actual race and the finish maybe. Then, we can look how each of these can be further decomposed. Say, step 1, create a racetrack with a start and finish line. Step 2, select and resize 6 sprites with at least 2 costumes to allow for animation. Step 3, work out how to get them all to line up on the starting line, and so on. Through working to decompose a problem and look at generalization within the program, pupils get to practice concrete computational thinking skills in a way that sticks. The session continues to look at a number of extension activities for more able students and at scaffolding for those children who might find it a little hard to code from a blank canvas. To do this here, the session explores how to set challenges to modify existing code rather than starting from scratch, as well as why and how this is a crucial approach for some children, as well as a wealth of resources and handouts that can be used to help scaffold the activity and offer targeted differentiation. There is no doubt that when you work with others or yourself through the whole session, then you will come away armed with a number of clear outcomes which you can develop further. These being, as I said at the beginning, to be familiar with the key concepts required to write programs, recognize the key 3 constructs used in every algorithm, appreciate the centrality of a variable, be familiar with functions and procedures, and recognize their role in structured programming, and how these combine to create a strong framework for teaching and learning in the classroom across Key Stage 3. If you want to find out more about how to attend, host, or develop a Tenderfoot session for your own school, please visit CAS Online and the Tenderfoot team.